Okay, this video I'm going to find the tension in T1 and T2. I worked similar problems like this on previous videos. This one I'm going to go into more depth. So the first thing to do is to draw your free body diagram or your force diagram, whatever you want to call it. So I come down here. I indicate a point for this. I take 10 times 9.8. That's going to give me the force coming down. Okay, I got T2 coming back up this way, so I push T2 coming back up this way, and I have T1 coming this way. Okay, now I'm going to label these with a lot more detail than what I normally would if I was teaching an AP class. So this would be the force of gravity. I'm not going to put any units on this. Force of gravity, and we'll call this the block, comma, and this would be Earth. That's what's causing this force. This will be T2. Again, it's acting on the block, and we'll just call it some type of force. We don't really know what it is. What's causing it? This one over here would be T1, comma, the block is what it's acting on, and this is again some type of force. Now we'll look at T1 by itself. Force come up here. The value come up here. It's going like this. Now this one's coming off the vertical, so we'll go ahead and draw the y component like this, and the x component kind of like this. We'll go ahead and stretch this one out a little bit. Okay, the angle right here is going to be our 70 degrees here. Go ahead and put these out here and we'll label everything. This is our T1. This value right here will now be T1 times the sine of 70 degrees. This one here will be T1 cosine 70 degrees. Okay? And we know that this one is going to the left, and we know this one's going to the right. Okay, we'll do the same thing for the T2. Again, I'm going in a lot more depth than what I would normally do, but if you follow this approach, it's really difficult to even make a mistake. So this will be our T2 here. Our angle here is going to be 50. So we can tell right now that this has got to be T2 times the sine of 50. And this is going to be T2 cosine 50. Again, as you can see here, this is going to the right, and this is going up to the left. Okay, now I'm going to draw another free body diagram, or force diagram, with all the components. I'll come down here, I'll put a point here. I will have this component coming down. I will have a component going this way. I will have a component going this way. I will have two components going this way. Now I'll label all these. I got, this will be T1, the sine is 70. This will be T2, sine of 50. We'll let this one be T2 cosine 50. This one here be T1 cosine 70. I've taken every one of these components that I created or showed from my triangles up here, and I'm bringing them back into this new force diagram or free body diagram, and this would be your force of gravity coming down here. Alright, looking at this, we have two x components and we have three y components. So we can say the summation of forces in the x direction is equal to mass times acceleration, but acceleration is 0 because the object is not accelerating. So we can just mark this out and make that equal to 0. Obviously we can do the same thing for the y direction. Summation of forces of y equal to mass times acceleration, but the object's not accelerating, so we just set those equal to 0. Alright, so we're ready to just put the values in. The summation of forces in the x is equal to 0. I look back here at my diagram, I will have minus T1 sine of 70 plus T2 sine of 50 must equal to 0. I look at my y components, I say the summation of forces in the y is equal to 0. I will have T1 cosine 70 plus T2 cosine 50 minus Fg, my force of gravity, must equal to 0. I can take this equation here, we'll solve for that. I will say that I'll move T2 to the other side, multiply by the negative to get rid of it. I can say that T1 times the sine of 70 is equal to T2 sine of 50. So can I not say that T1 is equal to T2 sine of 50 divided by the sine of 70? Okay, so we have that one. We've simplified as much as possible. We go back to our second equation where we have T1 cosine of 70 plus T2 cosine of 50 minus the force of gravity on that block is equal to 0. We substitute this back in here. We will get T2 sine of 50 over sine of 70 times the cosine of 70 plus T2 cosine of 50. We'll move the Fg to the other side, equal to the force of gravity on that block. Now we look at this, we could simplify. Again, I'm going into a lot more detail than what I normally would. Cosine of 70 over the sine of 70 is the cotangent. Okay, at this point, let's put the values back in and we can solve this problem. We know our block had we had 10 kilograms. That's 10 times 9.8. That's 98 newtons coming down. Put the sine of 50, cotangent 70 plus T2 cosine 50 is equal to 98. We'll get our calculator, we'll see what we got here. Let's do that, sine of 50. Okay, over here that gives us 0.2788 T2 plus cosine 50 0.6427, actually 28 T2 is equal to 98. We'll add those together. 0.2788 plus 0.6428 gives me a value of 0.9216. T2 is equal to 98. We divide 98 by that value. That gives the value of 106. So T2 is equal to 106.34 newtons. We have that value solved. Now all we have to do is take that, put it back into this right here. We can solve for T1. So we're going to multiply that by the sine of 50 divided by the sine of 70, and that gives us T1 is equal to 86 0.69 newtons. And that's it. Again, I went into a lot more detail than what I normally did, but I want you to understand where all these values are coming from. You can set these problems up without actually putting in the force. You can just leave this the way it is and set it as the force of gravity. The B represents the object that is acting upon, which is the block, and the object that's causing this force is Earth, and that's what the E stands for here. And then again, just work through this mathematically, and then at the end, if you want, you can go ahead and put the forces in. I like to draw two free body diagrams. I like to show one the way it really is, and then I like to show one with all the components. Alright? Alright, best of luck with these.